Hello, today we are going to talk about system of linear equations. As we all know that a linear equation is an equation that represents a line on a graph, and the best way to represent a linear equation so that it could be graphed is the slope-intercept form. The slope-intercept form, as we know, is represented in the form y is equal to mx plus b, and the reason it is called the slope-intercept form is because in y equals mx plus b, m is the slope and b is the y-intercept. So we take the two words slope, intercept, and call this form of the equation slope intercept form. This is not the standard form of a linear equation, but this is the form of the linear equation which is the best one to be graphed. Since this represents a straight line, a system of linear equation would be a system in which there are going to be more than one linear equation. So that means you may have at least two linear equations. If there are two linear equations, then they can form a system three different ways. First, if there is an equation y equals mx plus b, since there are going to be two, I'm going to call the second one y is equal to mx plus b. How would we distinguish the two with each other? We're going to put subscripts. So we're going to call this m subscript 1, b subscript 1, and the second one we will call it m subscript 2, b subscript 2, which means the values of m1 and m2 are different as compared to values of b1 and b2 are different. So as an example, I could say that y is equal to 2x plus 3 and y is equal to 3x plus 4. As you can see that each one of the two equations have a different slope and a different y-intercept, which means m1 is not equal to m2. Actually, the y-intercept really doesn't matter when the slopes are different. When the slopes are different, then the situation that this will create is you will get two lines that intersect each other. So if, arbitrarily speaking, if I say the first equation y equals 3x plus 4 forms a line that looks like this, and the second equation y equals 2x plus 3 looks like, say, this, then as you can see, they intersect at a specific point, and that is their point of intersection. Such a situation means that there is one solution to this system. So we say one solution. So all one has to remember is that if the slopes of two linear equations are different, then you will have one solution. Graphically, if two lines intersect, then there will be one solution. Second situation will be when the slopes are the same. If the slopes are the same, then I can say y is equal to mx plus b. I can put an example such as y equals 2x plus 3. And the second equation is y equals mx plus b. And let's say I have y equals 2x plus 4. Here, as you notice, that the slopes are the same, but the y-intercepts are different. This situation means m1 is not equal to m2, but B1, M1 is equal to M2, but B1 is not equal to B2. When the slopes are the same and the y-intercepts are different, that means I have two lines that are parallel. So the first line, y equals 2x plus 3, could be drawn and the second one can be drawn when they are the same slope, the lines are parallel. As you know that when the lines are parallel, they never intersect. That means there will be no common point. So whenever the slopes are the same but different y-intercepts, then we have no solution. That's the second situation. Third situation will be when the slopes are the same and the y-intercepts are also the same. That would mean that I have y equals 2x plus 3, and the second equation is y equals 2x plus 3 also. This means that the first line is a line and the second line is a line that is coinciding the first line. All points on both lines are common. This happens when M1 is equal to M2 and B1 is also equal to B2. As you could see, that when that happens, the lines are coinciding, and when the lines are coinciding, they share all the points. This is the situation when we say there are infinitely many solutions. Graphically, when the lines coincide, there are infinitely many solutions. And algebraically, when the slopes and y-intercepts are both the same, then there are infinitely many solutions. Thank you.